Okay, so just a quick announcement again. Today is the last class of 2021. All right, we'll continue on in January next year. So next year, our class timing is still the same, just for convenience sake. I do know that some people here, or I have received a few requests whether we can change the timing. Unfortunately, as of now, it's no, and I have only one class. A few alternative solutions is you can just get the recording and watch it some other time. Or maybe yeah, I don't think we can change timing as of now unless like majority of y'all cannot make it on the same time, which is Tuesday 8 to 10 8 to 9:30. Only if majority has problems with the timing, only we will consider changing the time. Okay, to those who have just joined in, we are just continuing on from where we stopped last week. So we still have one more question for MRSM paper 2. Okay, so we're just going to continue that and then we will move on to the next paper in a bit. So just take about a few more minutes before I discuss. Okay, let me discuss the answer for this one, 8D. All right, so diagram below shows the different conditions for storing food. Okay, condition A and B. So A is actually showing you a fridge, okay, and B is just open air or room temperature. Okay, so in which condition will the food last longer? Okay, so when you see this kind of thing, when you see lower temperature, you go for the lower temperature one. So when you see fridge, you say you will write fridge. Okay, so the condition A will be the one where the food will last longer. Okay, and then explain why. So condition A has lower temperature. Lower temperature. And we need to explain why lower temperature will be better. So this one has got to do with rate of reaction. Okay, so when at low temperature, your bacteria, okay, your bacteria inside has less activity or less reactive. So what happens, why the food can last longer, right, is because when it's so cold, the bacteria cannot be as active as usual. It's slower, it moves slower, it does everything slower, it breathes slower, it eats slower. Okay, and that's why the bacteria do its thing slowly. And what is happening is that the bacteria, usually it will produce a toxin. Okay, when they eat, when they metabolize, okay, the word is metabolize, when they metabolize, they actually produce a toxin, and this is the stuff, the toxin is the one that will make our food go bad. Okay, the toxin is actually the one that make our food go bad. So since the bacteria cannot do its thing normally, so actually you have less toxin being produced. Okay, so you can write bacteria. Okay, bacterial activity is lower, hence their toxin produced is less. Okay, and that's it. All right, so very easy. Okay, whenever they ask you about temperature and then which one will the food go bad faster, it's always the colder one is better. Okay, that's why we always like to put our things in the fridge, in the freezer, okay, to preserve the food. Okay, because inside the bacteria cannot move as usual. Okay, it's very slow, everything is very, very slow, so the bacteria cannot produce a lot of that toxin, and then no toxin means our food will still remain healthy, okay, or remain okay to eat. All right, so it's all about the toxin. Okay, question number 9. So diagram below shows the bicycle wheel rim made of two different materials. The iron rim is easily bent, whereas the alloy rim does not easily bend. Okay, so this is about alloy. Okay, so based on the diagram above, I'll explain in terms of arrangement of atoms why alloy rim is better than iron rim. Okay, so this one, the answers for alloy is always very standard. Okay, we can write in this way. So first of all, just explain that alloy rim is harder than iron rim. Okay, this is one of the purpose why we do alloy. So alloy is always harder and stronger than the non-alloy, the pure metal. Okay, so then now we start explaining in terms of the arrangement in atoms. So in iron rim, all your Fe atom, okay, or all your iron atom are at the same size. Okay, and in alloy rim, the presence of foreign atoms make the arrangement less orderly. Okay, once you disrupt the orderly arrangement, right, so what happens is that the layers of atom cannot slide easily. The layers of atoms cannot slide over each other easily. So the whole purpose of alloy is really because you have different size, then now you don't have order arrangement, and because of that, the layers of atoms cannot slide over each other, so you are harder. Okay, you're harder, or less malleable, or less ductile. Okay, it's just very simple. So whenever it comes to alloy questions, your answers are quite standard. Okay, you always will write in terms of like, oh, addition of foreign atoms with different sizes. will make arrangement less orderly. When force is applied, it's harder for atoms to slide over each other. So it's always just about these few points. Okay, addition of chlorine atoms and then less orderly, so it's harder to slide over. Okay, so that's all. That's all for the MRSM paper 2. Hope it's not too difficult. All right. Now we will move on to the next paper. I've just sent in the Selangor paper 2, Selangor paper 1 in WhatsApp. Okay, so if you could just take out that, just open that, and then we will continue from there. Okay, so Selangor State Trial Paper 2020. Let's start with the first page. Okay, so again, I'll give you about 5 minutes to do this. So the first page is usually the easiest. So I'll go through, I'll give you just a few minutes and then I'll start discussing. So I'll try to cover as many questions as possible today for this paper 1. If I cannot finish, then I'll send in the answers to the group. And then if you have any questions, okay, if you cannot solve the problem just with the answers, just feel free to let me know. Okay, so once you're done, just share me your answers so I can check them for you. Yep, sure, no problem. If you need to copy, just copy now. Okay, let me discuss. Okay, seeing quite a lot of answers coming in. All right. Okay, first one, which substance consists of atom? Okay, when we see atom, we are talking about alone. Okay, anything that comes alone. Okay, so actually the answer here is B because helium comes alone. Okay, so A, glucose, okay, C6H12O6. Okay, so you're not alone because you have 6 carbon, you have 12 hydrogen and 6 oxygen. Okay, so this is definitely not alone. Okay, for C, ammonia is NH3. It is also not alone because you have 1 N and 3 H. You are not alone. And D, copper 2 sulfate is not alone because you have 1 copper, you have your SO4. So you're not alone. So what's the trick here when you want to see what is an atom? I want you to just open up your periodic table and look at the names there or look at the symbols there. If that, so those are elements here. And if those, okay, the name of those, if you see the name of those coming by itself, like helium, okay, you can see helium in the periodic table, right? Just helium. So that will be means that it's alone. Okay, you don't see carbon dioxide. Okay, so that's 1 carbon and then 2 oxygen. All right, you are looking at just the one box. Okay, one box. Okay, your periodic table. One box is 1 element. Okay, one box is 1 element. And if the element is just by itself, it's just by itself. Okay, so for example, now I'm looking at helium. Okay, so helium comes alone, right? So you just take helium, that is means that it is atom. So atom means alone. Okay. Yes, so if you see Na, okay, just like that, if they just tell you Na, okay, yes, this is atom. Okay, if they tell you just sodium, this is atom. But then if they tell you sodium chloride, okay, then this is not atom already because you are Na plus Cl already. Okay, then you have 1 Na, you have 1 Cl, then you're not atom already. Okay, so when you want to see atom, okay, just find the name in the periodic table. If it comes alone, just exactly the name like that, that means that it's atom already. Okay, you just want to see that it's alone. Okay, just alone. And another trick is if you see group 18 substances, okay, group 18, we know group 18 always travel alone, okay, it's monoatomic, then you are definitely atom. Okay, definitely atom. Okay, group 18. So that's a trick. So second one, diagram below shows the atomic symbol of the element X. Okay, this one a lot of people got correct. I think this one's very easy. Answer is C. Okay, so the small number, okay, small number always is the proton number. And the big number is always nuclear number or mass number. Okay, so your electron arrangement for atom like this, when they give you atom like this, atomic symbol, okay, the electron number is equals to proton number. And then you just have to put in your electron arrangement. So your electron number is 11. So you have 2.8.1 to make up for 11. So answer is C. Okay, this one should be simple. Okay, third one. The mass of one atom of element Y is 2 times than that of oxygen. Okay, what is the relative atomic mass of element Y? So oxygen, we know the RAM given already is 16. So it says Y is equals to 2 times oxygen. So it's equals to 32. Very easy. Okay, number 4. Nitrogen and hydrogen react as shown. Molecule of nitrogen plus 3 molecule of hydrogen is going to give us 2 molecule of ammonia. So you know, for example, you know these numbers here are your mole ratio. So we can start off with just the shortcut. Just look at the numbers, whichever that doesn't have the same number, you can just straight away cancel out first. So I'm looking at 132. Okay, so 132, I can straight away take out this one. Okay, so this one is 111. Okay, so wrong already. So the rest, okay, then we have to take a look. So we know nitrogen, okay, nitrogen is N2, okay, hydrogen is H2, okay, and ammonia is NH3. So just look at the ones that give you this correct symbols and you get C. Answer is C. So when nitrogen and hydrogen, they react, when it comes to reaction, they will appear as their natural form. Okay, so although nitrogen in the periodic table, you know, nitrogen is just N like that, right? But For nitrogen, hydrogen, oxygen, chlorine, fluorine, okay, that I have mentioned many, many times, all this you have to put a 2. Okay, in the environment, okay, in our natural world, okay, it cannot flow or it cannot be N alone. Okay, it does not exist as N alone. Okay, it must be N2. So what's the trick here? What's the trick here? Is that if you are looking at non-metal gas, they are always diatomic. Okay, always diatomic. So that means you have to put a 2 there. Okay, so nitrogen is not metal. Okay, so you put a N2. So nitrogen gas is N2. Hydrogen is non-metal. Okay, so hydrogen gas is H2. Oxygen is non-metal, so oxygen gas is O2. Chlorine gas is not metal, so chlorine gas is Cl2, and then you have Br2 and so on. Okay, so the trick, okay, the shortcut method is just that if you see non-metal gas, you know they are diatomic molecule. But of course, if you are really doing this so many times, you'll be very, very familiar that nitrogen is N2H, hydrogen is H2. Oxygen should be the easiest because you know that you're breathing in oxygen and oxygen is O2. Okay. So answer is C. Okay. So next page. Okay. Another 5 minutes and then I'll discuss these 3 questions. All right, let me discuss. Okay, so number 5. Okay, this one should be very easy. Okay, what's the definition of empirical formula? We've seen this many times. So chemical formula is the empirical formula is the chemical formula that shows the simplest ratio of atom of each element in a compound. Okay, so C, and just another one. Okay, if you are asking for molecular formula, then the answer is D. It's the actual number of atoms. So it's either simplest ratio or actual number. So we are looking at either C or D. So empirical formula is the one that shows us the simplest ratio. So make sure you get this correct. Okay. So question number 6. Okay, empirical formula. Okay, so we have been not doing this for a very long time already. So I hope you still remember how to do this. So how to calculate for empirical formula? So we want to use a table. Okay, we want to use a table. So everything makes mom run slow. So everything makes mom run slow. Okay, it's just a table with 5 rows. Just want to do it one by one. So we have our element. Okay, so here we are already given. We have X, Y, and Z. And then the second row is our mass. We are given already. So we have 50, we have 15, we have 60. Okay, mole, mass to mole, divide by RAM. So 50 divided by 40, I get 1.25. 15 divided by 12, I get 1.25. 60 divided by 16, I get 3.75. Okay. Mole to ratio, third row, mole to ratio divided by smallest mole. 1.25 divided by 1.25, 1. This one also same, 1. 3.75 divided by 1.25, I get 3. If your numbers are all whole numbers, your simplest ratio is the same. Okay, as long as you're not having decimal, then you don't have to do anything. If you have decimal, let's say you have something with 0.5, let's say you have something with 0.5, then you need to make sure that you do something to make it the simplest whole number ratio. So if you have 0.5, then you times everything times 2. Okay, everything times 2. But here, because everything is already whole number, so I just copy down 113. So when I have 113 already, so I can write X, Y, Z, 3. Okay. So answer is B. Okay, number 7. Chemical equation that shows the reaction between zinc sulfide and oxygen. Okay, let me just write down the equation. 2ZnS plus 3O2. I get 2ZnO plus 2SO2. Okay, so this is a calculation question. When you have calculation question, always just start with what you have, what you want. Okay. All right, so let's start with what we have. We are given 38.8 grams of zinc sulfide. Okay, and we want volume of oxygen. So zinc sulfide I have 38.8 grams. This is our mass. And what we want is volume of oxygen. Okay, so once you have this already, first step is always to convert what we have to mole. So mass or mole of the zinc sulfide. Okay, when we are given mass, we just take mass divided by RAM. Okay, so equals to 38.8 divided by the mass of the relative mass of your zinc sulfide, which is given to be 97. Okay, they give you already. The relative mass for your zinc sulfide is 97. Put into your calculator, you will get 0.4 mole. Okay, when you have the mole of what you have. Okay, now we want to find out the mole of what we want. Okay, mole of what we want, you can use mole ratio. Okay, mole ratio of zinc sulfide to oxygen is equals to 2 to 3. 2 to 3. Okay, So this one is not too straightforward where you want to times 2 or you want to times 3 or just divide by 2 or divide by 3 because now you have different numbers here, 2 and 3. So what you can do is just do the normal boring mathematical way. So Z and S over O2 equals to 2 over 3. Okay, so again, the dot dot is actually divide. Okay, so Z and S we have already 0.4. O2 we don't know, just leave it. 2 over 3. Okay, so mole of O2 equals to 0.4 times 3 over 2. Okay, so equals to 0.6 mole. Okay, so now I got more of my oxygen already. Okay, let me just put this slightly to the left. Okay, then once you have your mole of your what you want, then you can now convert already. You can convert to your volume. Okay, so mole to volume, okay, times whatever they give you. So you are given 24, so just times 24, and then you get 14.4 dm cube. Answer is C. Okay, so next page. Okay, next page. Again, 5 more minutes, and I will discuss this page. If you want to copy for this question, go ahead. Okay, let me discuss. So number 8, this one should be easy. What's the vertical column of the periodic table? So vertical column, we are talking about this. Okay, so we know this one very clearly. It's just our group. Okay, so this is, for example, this is group 1, this is group 2, and so on and so forth. This is group 3, group 4. Okay, and then here's group 18. Okay, so the first one should be easy. So the vertical column is just group. Number 9. Okay, so if you have forgotten already this question, so which for the following elements can form acidic oxide? So what are we looking at? So in chapter 4, we learn there are 3 types of oxide. We have basic oxide. Okay, we have basic oxide, we have amphoteric oxide, and we have acidic oxide. Okay, how to identify them? Basic oxide is just metal oxide. Amphoteric, you only have one, okay, which is just aluminum oxide. And acidic oxide is just non-metal oxide. So if you have a non-metal combining with oxygen, this is our non-metal oxide, and this is our acidic oxide. So we just have to find a non-metal. So non-metal in our periodic table is just anything from the group 14 to 18. So in this case, you should be able to identify your answer as to be 2 and 4. 2 and 4, you get C. Okay, so calcium is not in group 14 or 18, and then potassium is not as well. So calcium is in group 2, potassium is in group 1. Okay. Okay, question number 10. This one should be easy. So which elements A, B, C, or D in the periodic table is suitable to be filled in electrical bulb? So anything that you see in electrical bulb, light bulb, you know we are talking about argon. We're talking about argon, and we know argon is in group 18. Okay, you can just take a look in your periodic table as well, or you can just look at group 18, and then you know the answer is C. And the reason why argon is suitable is because it is inert. Because it's inert, it will not react. Okay, so it will not suddenly explode like your light bulb. Okay, so whatever you want to put inside is unreactive. You want to put some gas that is unreactive so that it doesn't, suddenly explode because of reaction. 11. Which substances is made of covalent bond? So we know covalent bond is anything with, okay, anything that is made out of non-metal and non-metal. So ionic bond is metal and non-metal. Covalent bond is non-metal and non-metal. Okay. So again, non-metal and non-metal. Non-metal is group anything group 14 to 18. So sodium oxide, it's not ready because sodium is in group 1. Aluminium is not ready and magnesium is not ready. So we know answer is D. Okay. Okay, easy. So next page. Okay, about a few minutes for this one. Okay, let me discuss. So question number 12, okay, we are talking about a covalent compound. How I know is because we know that they are sharing electrons. Okay, they're sharing electrons, so we know this is covalent compound. Okay, if it's ionic, then you will see something like something with the positive here and then something with the negative there one. Okay, something like this. So if you see everything that is drawn that to show the overlapping here, you know this is covalent already because they are sharing electrons. Okay. So what is the properties of covalent compound? So answer is A. Okay, they are soluble in benzene. So benzene is actually a organic solvent. So how to know whether this is organic solvent or not? Okay, solvent we only got two types. We only got water. Okay, solvent we got water, and we have organic solvent. So if you don't see water, then this is organic solvent. So organic solvent you will learn more in Form 5. Okay. So organic solvent is anything with carbon. Okay, so benzene is one of it. The most important organic solvent for you in your Form 4 is ethanol. Okay, so if you are given in paper 2, you are supposed to write an organic solvent, just write ethanol. Okay. But if you like, let's say paper 1 now they don't use ethanol, but then it's not water, then you know it's organic solvent. Okay, so for covalent compound, okay, you don't have high boiling point. This one is the property of ionic compound. Okay, so this B, C, and D are the properties of ionic compounds. Okay, soluble in water, high boiling point and melting point, and then can conduct electricity in molten state. All these are properties of ionic compound. So answer is A, is for covalent compound. Question number 13. Thiosulfate ion reacts with element M in group 1 to form a compound. Okay, M is not the actual symbol of the element, doesn't matter. What is the formula of the compound? So we are looking at two ions that will react together and form a compound. You see this one, they form charge. You know, we are talking about ionic compound, and we have taught you how to know how to predict your formula, how to predict your formula for your ionic compound. So first of all, you need to put down the metal, the positive ion and the negative ion side by side. Okay, so this one they give you already. So you got your negative ion. This whole thing is your negative ion. So your positive ion. Okay, how are you gonna do? So we know group M is in group 1. So that means M has one valence electron. Okay, M has one valence electron. So either it is either 2.1 or is it 2.8.1 or is it 2.8.8.1. Okay, doesn't matter which one it is. But because it is in group 1, it has one valence electron. And to become stable, okay, it will donate one electron. Okay, it will donate one electron. Okay, it will donate one electron. When you donate one electron, you become M plus. Okay, no matter which you are, 2.1, 2.8.1, or 2.8.8.1, you will still become M plus because you will donate one valence electron to become stable. So the positive ion is M plus. And can you see here? You can just do the typical or the usual cross method. Okay, so just bring down the charge. Okay, in the opposite end. So just copy down the alphabet. 2, I bring down from the right to become here, and then S2O3, the whole thing is 1. So the whole thing is 1, so you don't have to write. So 1 is always hidden, so you can just remove everything here. Okay. So answer is M2S2O3. So answer is B. Okay. So the reason why I don't need a bracket here is because everything here is 1. Yeah. So 1 is hidden, so I can just remove it. So for example, if M is in group 2, for example, if M is in group, if M is in group 3, for example, if M is in group 3, you will donate 3 electrons, okay, to become stable. So you get M3 plus, and you have S2O3 2 minus. And if you do the cross method like this, you need to be careful. So 2 you still bring down is still 2. S2O3, because it came 1, okay, it came as 1, the whole thing must bracket, and here you need to put 3. Okay, because this 3 belongs to the whole S2O3. If you don't put this bracket and you just put 3 here, this 3, first of all, it looks weird. Second of all, it's only belong to O3. Okay, so if you're doing cross method, you need to be careful in this case. If you have the whole complicated negative ion is quite long, so you want to make sure you put a bracket so that the 3 belongs to also the S and also to belong to also to the O. Okay, but this is just an example. It's not relevant to this question. Okay, just to take note a bit. Okay, and this, okay, let's do this in a few minutes. Okay, let me discuss. So question number 14. All right. So which of the following represents the electron arrangement for the compound form when element X reacts with element Y? So first of all, we need to find out the electron arrangement. Okay, always start with electron arrangement when we do chemical bonding. So for X, okay, you know electron number is 3. Okay, so it's the same as proton number. So it's 3. And then for Y, the proton number, it's also your electron number is 8. So X electron arrangement is 2.1. Y your electron arrangement is 2.6. Okay, and you can see that this one will form ionic bond. Okay, this one will form ionic bond because X is in our group 1. Y is in our group 16. Metal plus non-metal, you get ionic compound. Oh, oops. Let me just bring that back. Okay. Okay, so metal plus non-metal, you get ionic bond or ionic compound. So when you see this one, first of all, we can just do the shortcut. Straight away look at the answer. If you don't see the setup for ionic bond, you can just straight away take away. So for ionic compound, you definitely see bracket. You definitely see something in the bracket and then with the positive and negative at the top. So this one I can just remove it. This one I can just remove it. So answer is either A or C only. So how to know what's the answer? So first of all, we need to predict the chemical formula. So we know X will become X plus because you will donate 1 electron to become stable. Y will become Y2 minus because Y will absorb or receive 2 electrons to become stable. To receive 2 electrons, you will become Y2 minus. And then you have to do the cross method. Okay, you get X2Y. Okay, you get X2Y. So this is our chemical formula for this ionic compound. So which means that you have 2 of the X and 1 of the Y. Okay, so just look at it. You know the answer is C already. You know the answer is C already because you're supposed to see 2X and 1Y. Okay, you're supposed to see 2X and 1Y. So if you answer A, that means you might be careless, or if you don't understand, now you should understand already. You need to find out the chemical formula before you can identify it's A or C. Okay. Question 15. This one should be very easy. Which of the following pH is strong acid solution? So we know pH is a scale from 0 to 14. The lower pH is stronger acid. Okay, more acidic. So answer is D. Okay. Okay, 5 minutes for this page. Okay, let me discuss. For question 16, okay, which substance is an alkali? So for this question, you have two ways to look at it and two ways to solve it. First of all, first method, okay, is just to look at our list of alkali that we know for our syllabus. Okay, alkali we only know of a few, which is NaOH, KOH, or CaOH2, okay, or NH3 ammonia. Okay, so you can just look at the list here and then just pick the one that you see. So answer is potassium hydroxide. The second method is if you don't remember this list at all, okay, then you will go for the longer method, which is looking at the solubility. Okay, so alkali is soluble. Alkaline must be soluble. So if you look at here, you can see that copper oxide, potassium hydroxide, aluminum hydroxide, they are all not soluble. Okay, so go back to our chapter, our source chapter. All core are not soluble, except if they have sodium, potassium, or ammonium. Okay, except if sodium, your spa salts. Okay, potassium, your spa, or ammonium. Okay, ammonium. So if you take a look, A, C, and D, they are all our core salts. Okay, not salt, our core. Okay, and they are all not soluble. Okay, they are all not soluble. So the answer will only be potassium hydroxide. Okay, if you have potassium, then you are soluble. Okay, so question number 17. This one is a bit tricky because the way they ask it, which substance is a salt? Technically, you would think that everything is a salt here, but what they are actually asking is by the definition of salt. So the definition of salt is actually ionic compound formed when the H plus in the acid is replaced by something else. Okay, is replaced by something else. Okay, and the something else is usually just metal ion or ammonium ion. Okay, so for example, so when we know this definition, it's very easy for us to find the answer for this question because we only know a few acids. We only know a few acids. One is HCl. We know H2SO4. We know HNO3. Okay. Don't need to bother about the weak acid for now. So what happens is that the H is replaced by something else. So let's say this H is replaced by Na, okay, metal ion. So you get NaCl. So this one is a salt. So for example, if you replace it with for example, lead, okay, replace it with lead. So you get lead chloride. Okay, so this is also a salt. So the salt from here, from the definition, is very easy for us to answer because we only know a few salt or a few acids. And you see all the common ones, you are not looking at the H, we are just looking at the back part. So if you can see something that ends with Cl or SO4 or NO3, then we know this is potentially a salt. Okay, because what we are looking at is the acid, and then the H plus replace it by something else. H plus replace it by something else. H replaced by something else. So anything ending with Cl, SO4, and NO3, they'll be salt. Okay, ionic compound will be salt. So here I will just take the answer C. Okay. Okay, for question 18. Okay, for question 18. Table below shows the pH value of two solutions with this concentration, but when you have pH 8, when you have pH 12, both are on the alkaline range. So both are alkali. Whereas now we can see that K is weak alkali because you are less alkaline, okay? And L is strong alkali. Because you know the higher the pH, the stronger the alkali, okay? Higher pH means more alkaline. Okay, so weak and strong alkali, the main concept here is really about whether you partially ionize or you completely ionize. So answer is A. Okay, so concentration B, this one is wrong already because it tells you same concentration. number of mole of hydroxide is also wrong already, because same concentration will give you the same number of mole, and the concentration of hydrogen in K is lower. This one doesn't matter because I mean it's wrong. First of all, it's wrong because we are not dealing with hydrogen ion. We're not dealing with hydrogen ion. And yeah, so for alkali, we are dealing with hydroxide ion. We're always dealing with hydroxide ion. Okay, nothing got to do with the hydrogen. So answer is A. Which of the following is a soluble salt? So this one we are talking about the 4 golden rules that we have. Either use no spa, supercup, copacmer, or core. Okay, so no spa, supercup, copacmer, or core. Okay, so just use these 4 rules and then find out which one is soluble. So from here, I know the answer is A. Okay, because for A chloride, we are looking at copacmer. We're looking at copacmer. So you are not lead, you are not silver, you are not mercury, so you are soluble. Okay. For the second one, silver chloride, also using copacmer, So copacmer, silver, I see silver here. So silver chloride is insoluble. Okay, insoluble. Okay. Calcium sulfate. Okay, calcium sulfate. So using supercup. Okay, so supercup, if you see barium, calcium, or lead, you are insoluble. So calcium falls under supercup. So this is insoluble. Okay, all no spa is all soluble. Yeah, just for information in case you've forgotten. And all core salts, as we mentioned just now, all core salts are insoluble except spa. Okay, so if you have sodium carbonate, sodium oxide, sodium hydroxide, potassium carbonate, potassium oxide, potassium hydroxide, ammonium carbonate, ammonium oxide, ammonium hydroxide, they're all soluble. Okay, so if you have, so the rest will be insoluble. Okay, so as long as you have no spa, if you have spa, then you are soluble. Okay, because go back to the first rule. Okay, all no spa salts are soluble. The first rule is always stronger than the fourth rule. Okay, so question number 20. Which of the following salt can be prepared by this method? So what is this method? So we see this method, we know this is nitration. So back to our flow chart, when it comes to salt preparation, you ask yourself a few questions. First one is it soluble or not? Okay, if it's not soluble, okay, if it's not soluble, you just go to double decomposition. Or precipitation method. Okay, and it's soluble. Okay, you ask yourself another question. Oh shit, sorry. Okay, so once you are, if you are soluble, okay, 1 second. Okay, if you are soluble, then you ask yourself another question. You ask another question, which is contain pass or not? Okay, sorry, not pass, contain spa. Okay, if you have spa, sodium, potassium, or ammonium, then you go for titration. If you don't have spa, then you go for acid reaction. Okay, so here titration. So I'm looking for something that contains spa. Answer is B. Okay, answer is B. Because you are soluble and then you contain sodium. Okay, soluble because you have sodium and then you also have sodium, so you are doing titration. Okay, let's take a look at zinc chloride. Zinc chloride is soluble and don't have spa. So this one you will do acid reaction. Copper 2 sulfate. Copper 2 sulfate also soluble, but at the same time you don't have spa, so you will do acid reaction. Okay, the last one also the lead nitrate, because you have nitrate, so you are soluble, but you don't have spa, so you are doing acid reaction. Okay, so only B is doing titration. Okay. Okay, next page. Few minutes. Okay, let me discuss. So number 21, we are talking about eggshell. Okay, when you see eggshell, when you see what is it called? The not eggshell. If you are talking about those clam, okay, the clam shell, or any shell. Okay, if you're talking about any other shell, okay, it's like your seafood shell.
Like calcium?
Yes, they are calcium carbonate. Okay, they're all calcium carbonate. Okay, so the question, if they tell you is some sort of shell, okay, some sort of shell, you're looking at calcium carbonate. So calcium carbonate is your shell. And then you see vinegar. Vinegar is our ethanoic acid. Okay, so the reaction between acid and carbonate, we know that we will get carbon dioxide. So answer is A. Okay, we know acid can react with carbonate to give us salt, water, and carbon dioxide. Okay, so answer is A. Okay, number 22. Which reactants are suitable to prepare silver chloride? Okay, so when it comes to preparation of salt, we first have to know whether it's soluble or not. Okay, so what is silver chloride? Silver chloride is AgNO3. So AgNO3, because I see, AgCl. Okay, AgCl, silver chloride. So silver chloride, to know whether it's soluble or not, you have to use copagma. Okay, because chloride use copagma. And copagma, we know that Ag is inside, so this one is insoluble. So this is insoluble. So if you are preparing insoluble salt, you straight away know that you're using double decomposition method. Okay, using double decomposition method. And what is double decomposition method? You have to use two soluble salts to react to each other. Okay, you have soluble salt 1 reacting with soluble salt 2, then you will get one insoluble salt and one soluble salt. Okay, so again, if you want to visualize, so you have your soluble salt here. You pour it into another soluble salt. Then what you will get in the beaker is at the bottom, you get a layer of insoluble salt. Okay, this is your insoluble salt. And on top here, you have your solution. This is your soluble salt. Okay, so to find out this one, the answer, you have to find two soluble salt reacting with each other. So silver and hydrochloric acid, this one wrong already, because silver is not a soluble salt. It's not even the solution. This one is pure metal. Pure metal is a solid. It's going to be like a silver strip or something like that. Okay, maybe just like silver strip or silver piece of metal. Okay, so next one, silver carbonate powder. You see powder, you know this is solid already, so we're not looking for this. So soluble salt and soluble salt 2, this one are both solution. These both are solution. So B also wrong. Third one, okay, silver nitrate solution. Oh, okay, got solution, and you know this is soluble versus nitrate solution. But the next one, chlorine gas. Okay, wrong already. Okay, we don't want to react with chlorine gas. Okay, we want to get two solutions together. So answer is D. Answer is D. So answer is D. So you see silver nitrate solution, this is soluble. Sodium chloride solution is also soluble. So two soluble salts will react with each other to get our insoluble salt, silver chloride, and then another soluble salt. Okay. Question number 23. Okay, chemical equation shows the reaction between sulfuric acid and lithium hydroxide. So what is the molarity used? What's the molarity of lithium hydroxide? Okay. So this one I typo. This one is supposed to be LiOH. Sorry. So H2SO4, okay, react with 2 LiOH will give us LiSO4, Li2SO4 plus 2H2O. Okay, so this is a calculation question, and this is a neutralization calculation. Okay, so again, every calculation question always start with what you have, what you want. So what we have, so we have 50 cm cube of 0.1 mole per dm cube sulfuric acid. So the volume equals to 50 cm cube. Molarity equals to 0.1 mole per dm cube. We also have 100 cm cube of lithium hydroxide solution. So volume is equals to 100 cube. and what we want is the molarity. So when it comes to neutralization, okay, you can just simply use the equation, very easy. MABA over MBVB equals to over, okay. So MA is the molarity of acid, volume VA is volume of acid. So you have 0.1 times 50. B refers to base, which is your alkali. So we don't have MB, this is the one that we want to find, but we have VB. So MB, I just leave it. VB, we have 100. Okay, and this AOB, this is just our mole ratio. So the numbers before your substances, so the numbers here. So A is 1, B is 2. Okay, just put in your calculator and you get MB equals to 0.1 mole per dm cube. Okay, answer is B. Okay. So this is one method. Okay, another method for neutralization is always just go for mole. Okay, you can always go for mole. So method one is always just to use the equation. Okay, the simple formula here. Method is always to look for your mole, just like any other way we will do. Okay, so let me just show you quickly how to use method 2. Okay, find mole. Okay, method 2 is always find mole. So again, what you have, what you want. What you have, you just find the mole. So I have mole of H2SO4. Okay, and we know all is a solution. In this case, we know mole is equals to MB over 1000. So just put that into your calculator. You get 50 times 0.1 over 1000. Okay, and you will get 50 times 0.1. You get 0.005 mole. And when you have the mole of what you want, then you go find your mole of what you have by using mole ratio. When you find the mole of what you have ready, then you go and find the mole of what you want, okay, in the mole ratio. So mole ratio is equals to 1 to 2, okay. So that means your mole of LiOH is equals to 0.005 times 2 equals to 0.1 mole. And when you have this already, you can go and find out what you want. Okay, find out what you want. So you have mole, and we know mole equals to MV over 1000. So mole equals to M, we don't know, V is 100 and over 1000. So just put that into your calculator. M equals to 0.1 mole per dm cube. Okay, so you can use two different methods. So one is just memorizing and using the formula MAVA over MBVB equals to A over B. Second method is just to find the mole, okay, conventional way. Okay, just find the mole. Find the mole of what you have, then find the mole of what you want, then find the necessary information that you want to find. Okay. So let's do these 3 questions together, these last 4 questions together. Okay. Question number 24. Which of the following could be solution Y? Okay. First of all, let's go step by step, yeah. So which of the following could be solution Y? When we look at this, I will start with this step. So solution Y, you put in NaOH, you get blue precipitate. You know this, adding NaOH, this is our cation test. When you see add NaOH or add NH3, okay, NaOH or NH3 ammonia solution, you know we are doing cation test, and cation test will give you some very easy colors or observation that you can straight away identify what is your cation inside. So if you see the observation is blue precipitate, that means you know you inside there copper 2 plus ion. So if I take a look at this one, I can straight away remove B and D. Okay, can straight away remove B and D. Answer is either A or C. Next one, okay, you're adding on with BaCl2 or PbNO3 2, okay. So when they are taking this to react with 2 other things, okay, you can do the long way, which is to do one by one, okay. You take copper chloride, for example, just take copper chloride, and then you try to react with BaCl2 and then see what you get, and then take copper chloride, you go and react with PbNO3 2, and then see what you get. And do the same thing for copper sulfate. React with PB, BaCl2, what you get, okay, and so on and so forth. This is the long method, okay, but I teach you a shortcut. When you see all of these are actually they are trying to do double decomposition. That means you will just change partner, So whenever they when they do a reaction, right, you can just take a look at the behind. Okay, you can just take a look at the behind here. Whatever that has the same and will not react with each other. Okay, so from here, right, I can straight away remove this one. The reason because I see chloride, and if I were to react with BaCl2, this is actually no reaction because you cannot react a chloride with another chloride. Okay, you cannot react a chloride with another chloride. So I'll just take away this one, and the answer is C. Okay, answer is C. But I can show you for the answer C. I can show you for answer C why you get this white precipitate for these two reactions. Okay, so let me just do quickly. CuSO4, if you react with BaCl2, because these two are soluble, you get double decomposition. Okay, then you will change partner. Okay, double decomposition, you change partner. So Cu now partner with Cl, and then you get barium. Barium go and partner with sulfate. So this is your insoluble salt. Your insoluble salt is BaSO4, and this is our white precipitate. Okay, and the next one, copper sulfate, go and react with PbNO32. The same thing happen. You partner, you get CuNO32, you get PbSO4, and again, this is our insoluble salt, which is your white precipitate. Okay. Okay, let me go quickly to question number 25. Which of the following is not a factor that affects rate of reaction? So this one answer should be very, very easy. Answer is donkey. So the ones that affect the rate of reaction is not concentration of product, it's our concentration of our reactant. Okay, nobody cares about the product concentration. It's how much you put in, it's not how much you come out. How much you put in will determine the rate of reaction, okay, not the what is coming out. So temperature, we know yes, it will affect. Presence of catalyst, we know yes, it will affect. Size also, we know yes, it will affect. Okay. So question number 6, okay. So which of the following, okay, can produce curve Y? So first of all, I do a tail analysis. So I know Y is higher than X. So that means tail analysis means that I have more mole, okay, more mole or more concentration, okay, more concentration. Okay, so this one, okay. So let's see what they have here. Diagram below shows graph of the volume of the hydrogen gas against time for the reaction between zinc and sulfuric acid. So curve X is obtained when excess granulated zinc is reacted with 25 cm³ of 1 mole per cm³ sulfuric acid. So which of the following must be done to produce curve Y? Okay. Okay. So here, okay, I replace it with, if we see A, replace granulated zinc with zinc powder, I won't get a higher tail. I won't get a higher tail. So no, you will get a higher rate of reaction, but you won't get a higher tail. Next one, add a few drops of copper 2 sulfate solution. This one, they are suggesting to put a catalyst. So you are trying to put something foreign, then this one is actually a catalyst. So this is not the answer. Because giving a catalyst, you will not produce a higher concentration. You will not produce a higher mole. Okay. C, replace 25 cm³ of 1 mole per cm³ with 25 cm³ of 2 mole per cm³ sulfuric acid. Answer should be C. Answer should be C because you are increasing the number of mole. Okay, you're increasing the number of mole. So answer should be C. Okay. Okay, so let me just go quickly to the last question. Okay, so that we can close off to this lesson. So what is the overall rate of reaction? Okay, what's the overall average rate of reaction? So we know rate of reaction, very simple. We just take quantity over time. We just take quantity over time. Okay, and quantity, when you're given this table, you should be very, very careful because first of all, you need to know which quantity to choose. Okay, which quantity to choose. So here you have quantity you already have. Okay, the maximum quantity you have is 50. So this one is not too difficult. So just take quantity because they are mentioning overall, means you're taking the one that's ending. So you are taking the maximum, which is 50. 50 is the one that is ending. So the time is the one that's tricky also. So you want to take time, which time you want to take? you must take the one as soon as they become maximum. So you want to take this 180. Don't take 240 seconds. You want to take 180 because at this 180, the reaction ended already. So the reaction ended already. So you want to take this quantity and this time. Okay, so don't take the last one. Don't take the last one because you need to see which one is the one that reaction ended, and reaction ended as soon as the maximum has been achieved. Okay, as soon as the maximum has been achieved, that is the when the reaction has ended. So you want to take 180 seconds, but here there's a problem because when you see the answer, your unit is in terms of minute. So you cannot use seconds. Okay, you cannot use seconds. So you will get, okay, you will have to convert your 180 seconds. It goes to 3 minutes. Okay, it goes to 3 minutes. So I divide by 3 instead. So if you divide by 180, you will get a wrong answer. So 50 divided by 3, I will get 16.67 cm cube per minute. Okay, so answer is D. So don't be careless. If you don't take it as minutes, if you divide it by 180, you will get answer B. You will get this, which is wrong. Okay, so be very, very careful with the units. Okay, so that's all for the paper 1 here. We have finished the entire paper 1. So I'll stop here for today. Okay, I'll stop here for today. If you need my digital notes, please let me know. Again, today is our last lesson for 2021. I hope you have gotten a very much clearer picture of the whole syllabus of Form 4, okay, considering that we have done quite a number of revision. It's okay if you are still not very familiar with everything. Of course, that's normal. When you do your revision, try to take a look at all these questions again that we have been doing the entire month. So next year, Form 4, next year, January, we will still do a bit of revision. We'll still continue to do some past year and state trial papers. And then in February, we'll start our Form 5 syllabus. Okay, so with that, I will end this year's lesson. Okay, again, sincerely thank you everyone for staying with me throughout and being such good students. I hope you guys take a very good break in December. Okay, please continue to stay safe, stay happy, and stay healthy. And I'll see you guys next year. All right, good night, everybody. Take care, everyone.